the last one.
Yeah.
Loghman was here. So just for those of you who don't know, we are Gravity 9. We're a product development company, so we build software for large enterprises. As part of that is AI, as part of the intelligence within the products that we do build. Loghman is our AI lead. And today he's going to be talking about generative AI. So just one ask is if you could turn off your phones, because we're recording, we've got a couple of guys on the end there, but away from that, I think we'll get going.
All right.
Over to you, Loghman.
Thanks, Noel. So, yeah, I think as Noel mentioned, our topic is generative AI and computer imagination. I think is a interesting topic for lots of people. Basically, every day we see some new progress in those areas. So, in this session, I will try to we will try to somehow go around the concept of generative AI, finding what is it, and what kind of application Gen AI can have, where we can use the Gen AI capabilities, and then we will go back to the history by looking at the first attempt to creating models or neural networks to be generative, specifically by looking at the generative adversarial network or GANs, and then diving into a little bit, not too much, the technical aspect of, for example, models such as the diffusion models and large language model at the end, because they are important part of the generative AI, specifically I think after the ChatGPT, the rising of the hype about the AI. And attention mechanism and transformer, which is the heart of, or the main concept around the Gen AI. So, when we are saying generative AI, in fact, we refer to group of or AI systems that they can generate high quality data. So, data could be text, image, audio, video, and they are really generative. Sometimes there is a debate, they are not creative, in fact, but they are generative. Why? Because creativity is, I think, a unique aspect of our human. And as a human, is so different. I think it's nice to start. Today we have a lots of visual elements, and the first one is I think one of the Prime Minister of UK, he tried to help us with today's presentation.
Boris Johnson, the former Prime Minister of the United Kingdom. I am here to help Loghman with his presentation regarding the introduction to natural language processing. This video, including me, was generated by AI and natural language processing systems. Loghman will explain the concepts and show you how computers can understand our language and generate speech or text. Hope you find this presentation enjoyable and informative.
Yeah. I guess he's not really away. These days he has time for that.
Yeah. So in fact, this is an example of generative AI. I work on a project, and beside the project, at the end, because I deliver some lectures in the university, so for the natural language processing module for the student, I created that video. I just said, let's bring Boris to this session as well and get some help from him. Yeah, there is lots of elements, specifically from the synthesizing the voice, the image, and finally the whole video. All of them generated by AI models. So in fact, these, as an input for this system, I passed 5 samples of audio, short audio from the Boris Johnson with a photo of him, and the system created the video for us. So, video generation is one aspect. We have lots of new aspects, specifically with the visual element, and combining text with images. This is a very new, I think, model. You can check the photo maker if you like. It's I think 2 weeks ago they announced this model, and it's really nice. I passed my photo on the top and then a text to help the model to understand what I want. The first one, a man in space wearing a space suit, and this is me in the space. And the second one, I'm so excited on the stage and try to deliver a speech. So in fact, it makes a very new area. I think we can see generative AI can or capable to generate different type of data. And the last one is a text. I think is one of the most advanced, I think, improvement in this area. In this example, I created a GPTs. As you know, OpenAI introduced, and now you can create a bespoke GPT or chat GPT for yourself. So I created a GPT as a personal trainer, and I asked the GPT to give me a plan for exercise and somehow losing weight. And this is just part of the conversation, and it's really good, to be honest. Yeah. Generative AI capability. So what we can do with Gen AI is important. There is a different area. If you want to, for example, look at different area, we have language, voice and audio, vision, image and video, and enabler. In the language area, problem solving, to grab there, there's a pointer, I think it's easier. Problem solving, communication, interpret and extract info, analyze and transform, and generate information. Those are some capabilities that we can think about them. For solving problem, for example, we can use the generative language model to follow our instruction to do specific task, or we can use them for reasoning, making recommendation. As we saw in the last slide, it gave me or recommend me some sort of exercises to follow. Act as an agent to do specific task. Or for the communication, they can hold the communication conversation with the people, personalizing message or mimic a specific style or behavior. Explain and execute is another capability, specifically in the communication area.
And the recommendations then, because that's been a technology that's been around, recommendation engines. How is it different, or how has it improved sort of that experience through generative?
So in fact, for the recommendation, I think we have the system or the AI model, they have more understanding compared to the context. Mm-hmm. So context awareness is the area that can help, that improve the recommender system specifically when you have more understanding about the context. Let's say, for example, when you want to recommend an article to a person to read, having a better understanding about the context of the article definitely improve the process.
So sort of broader base of information, so you can pull that in rather than the fixed parameters in a like more traditional way. Yeah.
Exactly. Also, I think from another aspect, because generative AI can understand the visual element as well and explain them for us. So somehow, it's just not a text recommendation. They can recommend, for example, videos, images, and different data modalities. Yeah. And interpret and extract information is another capability. So we can use the generative AI model to assess our situation specifically around the compliances and recognizing entity acting as a entity recognition systems. So, for example, extracting the name of the entities, organizations. So it's one of the major tasks or main tasks in the natural language processing that new generative AI model can help us. Or extract structured data. For example, if you have lots of documents, now you can convert the information inside those documents to a structured format or a table. I think
data points. I mean, that's an example of a project that we've sort of built actually numerous solutions recently, where we, large, quite complex terms and conditions or product spec type documents, and being able to tease out, key points, information, and bring it into more metrics and show those as a table. So again, it comes back to efficiencies. Like, you don't have to read the whole document to get the, that key information that you're after, which seems super powerful and quite quite popular right now. We're finding.
Exactly. So I think RAG or retrieval augmented generation is some sort of those application. Specifically, when you have a bunch of documents and then you want to extract specific, or you are looking for specific part of the information and you want to put them, for example, in a structure. And this could be one of the application of generative AI.
That's helping with comparison as well, so you can extract key information out of multiple documents of related things and multiple products, for example, and then you could efficiently sort of compare those things through just providing the information in the document, and then compare them apples to apples through, that converted data. Is super useful.
Exactly. Analyze and transform. So we can, in fact, classify data or summarize information, detecting sentiment and emotion. And I think
it's a bit like recommendation, isn't it? Like, is that that's been around a while? Like sentiment analysis. Like, how is this helping improve that? Because we've seen those sort of, that's kind of a smiley sentence. Or like, I wonder if you could expand on.
Yeah, I think specifically for sentiment analysis, generative AI somehow improved the quality of identifying the sentiments. So compared to the traditional techniques, because I think we can say lots of traditional algorithms, they are based on the statistic and probability of acquiring some specific of words in the document, and then they try to count, for example, those words in the document, then specify the sentiment based on the count of those documents. But now, as I mentioned, having the context can help specifically with the detecting emotions.
So a similar thing, then more information just means more accuracy. Is it like a limit to the amount of text you would analyze per sentiment? Is it
100%? Yeah.
Because this sort of correlations, the whole document might have lots of different sentiments along it. Is that
Exactly. So I think because the amount of the data that generative AI models trained is huge, is not comparable with the traditional models. So in fact, having lots of data for training improve the performance and the quality of the output. Yeah, and because of that, definitely we can expect to have a better understanding. Rewrite the text is another application or capability. For generate information, I think today everybody generates lots of information, but with the AI, I think we try to boost that one, and now generating text. Syntactic data is another very interesting area, specifically if you are a data scientist or machine learning specialist and you have a small data set and you want to create a system that can somehow understand better or generalize better, so you can use the generative AI model to create new data sets.
Does that cause any kind of hallucination in the model? Like if you're generating data and then processing it, is there any complexities there?
Oh yeah, 100%. This is one of the aspects that should be covered or evaluated during the process. For example, let's say if you want to create a data set, so what kind of distribution you want to have for specific data? Do you want to have for example, a binary distribution, or do you want to have a skewed data toward a specific, for example, range? So there are lots of things that should be evaluated in the process. Code generating, that is, I think, yeah.
It's taking my job.
Yeah.
No,
Lots of developer.
Yeah, exactly. But I think it's like the efficiency side of things, isn't it? It's like generating some of the boilerplate code and unit tests, like in my experience. But have you seen anything beyond that where, you know, it's capable of pulling a full solution together and implementing, you know, that correlation between front and middle tier? Is that even?
Yeah, I think there is some progress specifically in this area for code generating. As you mentioned, for QA, code generation, it could be really useful for example, generating different testing scenarios or somehow creating unit test code. But from the other side, we can use with the multimodal model. For example, if you could fit the model with because there is some sort of model is emerging every day. They try to get a sketch of, for example, an interface. They try to generate the code for you.
Yeah.
So, such as, for example, HTML, CSS, or JavaScript for a website, or maybe more advanced. We hope to have a very sophisticated model that can put all the interaction and code together to create a fully functional system. But we are in the early stage. At the same time, for improving the performance of the developer team, I think having assistants such as a co-pilot or any other those kind of, I think, system definitely improve the performance and efficiency of the developers. So if you go to the other side, vision and audio, a new model can understand the voice, and I think it's a traditional, some sort of application of generative AI when they can, for example, translate or understand language directly or voice. Translating, because as a tradition, we try to transcribe the voice or the audio, generate the text, then translate to, for example, text from one language to another language, and then generate the destination, for example, audio. But now we have some sort of models that they can directly translate or create new voices from one language to another. Voice output, as I mentioned, voice generation, as we saw for Boris Johnson, that was just a sample. For music, I will try to show you an example in a following slide. Voice cloning, this is a very interesting application. I think I mentioned in one of the sessions. In Hollywood, to save time of the actors, they created the model that is personalized based on the voice of the actors. And so instead of inviting the actors to the studio to record the voice and read the script of the movie, or I think
they just generate.
Exactly.
Good for cartoons, I suppose.
Definitely. It's more productive, in fact.
Mm-hmm.
Yeah. Translation and voice cloning, as I mentioned. And if you go to the vision, we have some sort of core application or capability with some complex. The core is very basic, as we know, object detection or recognition and image classification. There are some sort of application for generative AI. It's improved. It was exist. We know, I think it's a part of the classic machine learning, but with generative AI, somehow we have a better quality at the moment. And with the complex capability, so they can understand content of the visual elements specifically. with the vision model that we have. So for example, GPT-4 is able to explain the content of the photo for you and based on that generate the text. So it's a very new and niche area. Visual reasoning, video understanding, feedback on image also, there is some sort of other capability. I think if I want to give you an example, I used to work on a project for a football club. So I think I mentioned, but we use the video as an input to analyze the player positions and predicting the location of the ball in the 2 or 3 seconds in the futures. But I think with generative AI models is much feasible and easier. And I try to divide those, in fact, vision and image and video. They are very similar, but in fact, there is some differences. So with the image, in fact, we can generate image from the text, as I show you, or image editing. You can easily edit an image. For example, I have a photo, but I like to change this photo to smile instead of. So we can edit that one with text or maybe with interaction component. Image to image, translating or transferring style from one image to another image. I will show you some samples in the future slides. And text to video. Now we have some models that they can generate video. And interestingly, I think it will revolutionize the process, I think, the industry of movie makers. And finally, we have the enablers. So this one, some sort of tricky one, I can say.
My understanding of an enabler is a bit of an extension, like a plugin. So the model
Exactly.
does some stuff, and this is almost like a reach out from the model to do things. So
Brilliant, yeah. That's exactly what I want to say. So in fact, we try to add some functionality on top of the generative AI, such as, for example, search and extract. So if you have a paid version of the ChatGPT subscription, you can ask, for example, to search the web for you and extract information from the web, or integrate with tools, combining or integrating the system with the API specifically.
could that be a point where you'd extend that and talk to your own systems and enablers, build your own adapters out from the model to execute?
We hope to, but I think we need more progress before to reach that point. Execute code or translate or transcript. There are just some samples. So this is, I think, a big picture of the capability of generative AI. Application of generative AI. I mentioned some capability, but I believe see some applications or systems in the real world could help. So the first one is music generation. I think there is a multiple application or samples, but we have new model that they can generate music. For example, I use the Musicify. Musicify is a simple model, or is a system that you can send a prompt. It's a text, and it will generate music. For example, I said generate an Iranian dance style music using different instruments. So let us see and hear the output. Yeah, this is a sample, and as you can see, is really, really good. Or I think 2 weeks ago, Meta also announced another model, AudioCraft from Meta. You can check on the internet. You can generate different type of music. And for Musicify, I think one of the interesting things, you can generate with the text, or you can play something or create as a vocal. You can record your sound and it try to generate the same music using the different instrument for you. Creative art, creating, I think, if you heard about specifically the competition, I remember 2 years ago, a model created a piece of painting and they try to go to what?
Try to sell it.
No, not sell it. In fact, they won a competition and it was surprisingly really good. So, yeah, now we have lots of different models. I put just some samples, for example, Leonardo AI, or if you want to, for writing, to be creative, I think Bart from the Google or ChatGPT, we have lots of, I think, models today in this area. Entertainment and media, movie making, as I mentioned. For example, emo, let us see. Can I show? Maybe I can show just one sample here by bringing that one to this side. So, for example, this is a new model introduced around, I think, 2 months ago by Meta. So they try to create animations or movies using just simple text as an input. And as you can see, it tried to adjust the characters, the environment based on the descriptions that you have. Yeah, I think this is just some basic examples. Then I need to go back to my presentation just to find out, yeah. Or for video game, for example, NVIDIA tried to create a framework and they announced specifically for people who they really into the game playing. They try to create virtual characters and improve the quality of the games. Virtual reality, Roblox is an example. Education and training, I think you might have the opportunity to come across one of those applications. Specifically, I use the Turnitin and Synthesia, both of them, and they are really good. For example, Synthesia tries to create an instructor for you. So instead of speaking by myself, to create an educational video or maybe a sales or promotion video, I can have a character and it will follow the text and read the text and speak for the one. Or in the science and healthcare, lots of companies try to, in fact, use the generative AI, specifically in the drug discovery, as I mentioned, I think in the first session, to find new kind of medicines. Technology and engineering, code generation, if it just to be very specific. Or in the automotive design, Toyota tried to use the generative AI to design the interior and exterior of the cars using the generative AI models. Or robotic, I think it has lots of application in the robotic to train the new systems. Business and finance, we have systems such as both Chat AI for market analysis or data rails for financial modeling or picture frame, which is really interesting. They're based in Manchester and I meet them. They try to be really creative. For example, you have an online shop and the quality of the photo that you have is not good or is not perfect for putting on the shop. Or you have your shop, you have the photos, but you want to attract more people from the specific range of age or with specific type of characters. So they try to help you to completely redesign the product photos. Yeah. Then marketing and advertising, I think, is another area. Personalized marketing. There is a framework such as Jasper AI, or for branding, I think especially lots of creative people try to use the Canva to, I think, harvest the power of the generative AI.
Sound down.
Oh yeah, sorry. Yeah.
Is the amount of content being generated and putting back on the internet causing, is that causing an effect on the accuracy of the new models using the internet? So it's like if everything is generated out on the internet now, and a good percentage is, especially around marketing, is that causing some dilution in the source? I mean, I guess it's similar to the earlier question, like does generating your own information artificially affect the results? Because I think that's what's happening, and maybe some of the latest versions of ChatGPT is affected by the fact that a lot of the content coming in is actually regenerated. So that, how does
Exactly.
that
Exactly. I think this is a very important point. So specifically when we try to reuse the generated data by the AI system for training future models, there should be some guardrails and revising process before training them. Yeah. Because at the moment I remember specifically when the ChatGPT came out, and lots of specifically, I think, people in the academic area, they get really worried about how to, for example, find out those documents generated by students or ChatGPT. And straight away, scientists try to provide and create a model just to identify the content that is generated by the AI from the humans.
And I guess that's related to the discriminate type pattern when you're trying to understand if something's real or not.
Yeah.
It's a constant battle between what's real and what's not, working out those things.
Exactly.
I know you're coming on to that. So.
Yeah. And another thing I think is nice to know, there is a technique, watermarking, and for a long time, I think specifically big brand try to invest on that to somehow watermark the information generated by the AI, and having a system to identify those content. And I think around 3 months ago, the DeepMind team from Google, they try to achieve this, I think, purpose. So in fact, they created a system that can watermark the content without impacting on the content, despite the modality of the content. So it could be an image, video, text, or anything. And you cannot see anything, in fact, in the output, but there is an algorithm that can identify easily the generated content. Any comment, any thoughts from the audience before moving to the next?
With the different sorts of generation, text-based, image-based, sound-based, is it a different fundamental idea that's happening beneath that generation, or is it the same fundamental idea?
That's a great question, exactly. We will dive into the following slides to see how we can generate those. What kind of techniques exist to generating those kind of information. And when we are talking about generative AI, the impact of those technology on the market is really important. I think I just tried to show you some numbers, but you can find lots of articles on the web that they try to show different figures and predicting the impact of the Gen AI on the market. For example, McKinsey, they said Gen AI added around 2.6 to 4.4 trillion in annual income benefit in one research. Or based on Goldman Sachs research or survey, they said Gen AI drive around 7% or around 7 trillion increase in global GDP. And it will lift the productivity by 1.5% over the 10 years. And the last one is really interesting and really shocking. From the OpenAI and University of Pennsylvania. They said Gen AI impact 10% of the task that carried out by 80% of the people at the moment. So in fact, it can, somehow we can imagine how it will transform the way that we try to do our job or work.
That's 80% of the workforce, like current workforce.
Exactly.
Will be affected, 10% of that population will be affected.
Yeah, 80% of the population will be affected. The 10% of their work, will be affected by the Gen AIs. And this is another just example. So they try to analyze the conversation or all the conversation in the stock market, specifically for S&P 500, and they found how much AI word is used in this conversation, and they show specifically after the ChatGPT, we can see how it increased. So it shows the investment going toward the AI and generative AI somehow. Yeah. So in this section, we will go back a little and look at some of the fundamental concepts, where it started Gen AI and what kind of network do we have. At the beginning, I will try to... Yeah.
Sorry, there was one question earlier which I think you're going to answer now, which we put back, but the question was, what the difference is between the different types of media, so text, image, video, and the question was really, is there a difference in how that's processed or reused? And I think you're about to...
Exactly.
Let's call that out.
Thank you for reminding me. Yeah. I think, now we can see how we can generate different data. So the first attempt was started with autoencoders. So autoencoder is a group of neural networks. When, in fact, if you try to go back in the normal situation, we have a neural network and we try to pass some data with the labels. So we have the label, we have the data. We pass the data through the network and predict some things. Based on the prediction, we try to train the model and go back. And during this loop, our network will learn to predict the output. So this is some sort of supervised learning because we have the data, we have the label. But what will happen if you don't have any label? And if you want to regenerate the same input in the output? So this is the answer, autoencoder. In fact, if you want to pass an image to a network and create a system that can generate the same image as output. So we have autoencoder. In the autoencoder, what we have an encoder. So in fact, there is a two network. One encoder network, one decoder. The encoder tries to extract the features inside the input and store them inside the latent space. These latent spaces look like a memory. And then the decoder uses this latent space to regenerate the same image as output. And we have a loss function. We try to iterate this process and improve the quality of the encoding and decoding. And finally, when we reach a specific threshold, for example, if the quality of the output data, let's say 80% equal to the input data, then we can remove the encoder, take the decoder with the encoding space, and use them as a generator to generate new data. So this was the first attempt to creating a generative AI models. And they are still in use. I think this is the basic concept behind the generative AI models.
Is that a harder problem to solve, effectively affecting an original item rather than just generating something from scratch? So that's what you're saying is it's probably double the work.
Exactly.
Evaluating the input and then relationships to that, and then generation on top of the relationship. So.
Yeah, in fact, what we try to do in this process, because we don't want, at the beginning, we don't want to generate any new data. We want to train and somehow embed more information inside the latent space. We want to have a very enriched latent space, or it looks like a knowledge base when you try to store lots of information inside that. So by feeding data and pushing the decoder to use this latent space to reconstruct the same input, we try to give more knowledge or store more knowledge in this latent space. And then when we remove the encoder part, so we have a great, look like a database of the information, and we can use that now for generating new data. So in fact, after that, we don't want to recreate the same input. We want to be generative and generating different concepts. Yeah. Before going to, so autoencoder was the first attempt. After that, we had another type of models. But before understanding that model, let's look at the real world scenario. So think about the counterfeiter who try to create fake notes, okay? And there is a policeman who try to identify fake note from the real note, in fact. So each time there is a competition between these two entities. The policeman try to be better in identifying the fake note, and the counterfeiter try to be better in generating a note that is really close to the real note. So it is in fact, a min-max competition between these two. Policemen try to maximize the chance of identifying that, and the counterfeiter try to minimize the chance of identifying. The same concept apply in the generative adversarial networks. So, in the generative adversarial networks, we have two different models again. One is generator, and one is discriminator. So, what we as an input, generator will receive some noise as an input, and then it will try to create data. Then the generated data with some real sample pass to the discriminator, and the discriminator try to distinguish between them and say, is the generated data is equal to the real one or not. And this process will continue until generator become enough professional in generating data. So in this case, I just show you some, for example, photos, but the same things could be applied with the other data. The input could be an audio file. It could be a text. So just to answer your questions, in fact, by changing the source data, we can use the same architecture to generate different data. And then when the generated data by generator has enough quality, we will remove the discriminator, and we get the generator just to generate new data for us. And this is the process. And for example, this is some photo that generated by the same structure. Just to show you some code, I'm trying to display a very simple example. So in this example, we will try to create a model, GANs, so Generative Adversarial Network, to generate handwritten digit for us. Okay, let's see the code. It's very simple, as I mentioned, but I'm just trying to give you an idea. So in fact, I use the PyTorch as a main framework, and we have the MNIST dataset. MNIST dataset is a dataset, I think if you remember last session, I showed you the handwritten digit from this dataset. It has around 10,000, it has around 60,000 training example with 10,000 test data. So, and then what we have here, we use this data set for training a generator. Just to give you an idea, there is one class, it is generator, is a neural network with multiple layers. I'm not diving into the detail, I'm just trying to show you what is the structure, and the training will be done using the forward method, and we have the discriminator. So very simple structure for our model, and we try to create these two model and train them using the data set. So just to pass the detail, what I did, I said let to train them for 20 times. So I passed the whole images 20 times to the models and help the generator to generate handwritten digit. And unfortunately, the output was terrible. And this is the important point that I just want to remind. If you want to create a generative AI model, you need a lot of computational resource. It's not easy to do on your own system or a free tier app, for example, cloud platform. So as you can see, after training this model, our generator is I think the quality is worse and worse. In fact, instead of getting better. And the discriminator, in fact, could recognize them better. So in fact, what I did, I said, okay, leave it. There is a trained model for this. I downloaded that model and I used that one. I said I cannot achieve. So this is some samples of those generated handwritten digit using that model. But I followed the same concept, so it just need more training loop to get the quality. Yeah, and for example, I said that to create some more example. As you can see, some of them doesn't make any sense. For example, some of them is not similar to any numbers, but you need to be creative to find a close, for example, number to them. So this is just an idea how to implement, how to have a generative or GANs model. Any comment, any thoughts? Okay.
Clear.
Great. I'm happy that's it clear. So, style transfer. I think we have lots of things. I will be a little bit faster to cover all of them. Style transfer is another type of GANs. When you try transfer style from one photo to another photo and train two GANs together. For example, in this case, you have the horse and zebra, and we have two GANs. One GANs try to convert the zebra photo to horse, and the other one try to convert the horse to the zebra. So in fact, we have 4 models inside. 2 models as a first GAN and 2 models as a second GAN. And we will try to use a cycle for training them. There is a different architecture such as a cycle GAN, big GAN, pix to pix, and you can find more, and I will share the resources in one of the slides if you like to read more about them. But it has a really interesting application. So again, me in a
I think it's going to be a sponsored beard growth. over the next couple of weeks.
Yeah, and maybe around 20 years later. So those are just some samples of the applications when we try to use the style GAN to add some element or adding some sort of style. So it's possible, for example, now to change the style, for example, making people smile, making them older, younger, or maybe apply more filters on the faces. I think it's one of the main applications specifically in the Instagram today or those social medias. Again, if you want to go back, the style GAN is another type of generative models. They introduced around 2017. Those type of architecture that I'm trying to present today, all of them, they started from 2014. So just think about that. The age of lots of these models is less than 10 years. And how we speed up the progress of, or the pace of the progress in this area is really high. So in the style GAN, what we have a concept of progressive grow GAN. When you have multiple GANs, just to improve the resolution of the output or the quality of the output. So for example, in this case, we have 3 GANs. It will try to start with a very low quality data and then increase the quality step by step. And at the same time, we can feed other styles with inside the architecture. For example, in the style GAN, we have a mapping network. In this mapping network, we try to create different style or generate different style as an output. For example, one style could be to change the face to smile. One style could be to change the color of the hair. One style could be, for example, to change the pose of the head, and so on. So, in fact, with this structure, we can create high-resolution photos with different style. As an example, this is an output. So, this column, or the first column here, if I want to show you the source A, as you can see, this is our source image. And we have the source B, which is the style. So, in fact, if you apply the style of this guy on this photo, which is a lady, the result will be that one. So it looks like a multiplying them together. So, in fact, if you go further, this is the applying the style of this photo on this photo, the result will be this. So, I think you can see how we can transfer style or use the style of one photo, apply the same on the other. Yeah.
We did have some thoughts on how to validate that, but probably I might ask if there's a couple looking to have a baby and we could maybe come back in 10 years' time.
Yeah.
But this is, I mean, that complexity though, to be able to take one thing, that person and that person, it's not like the bitmap you'd have seen, 15 years ago. It's taking characteristics and race and everything into consideration, so they're presumably a very broad model. Yeah, that's true. In fact, so they use the faces because I think it's easy to understand the faces, but you can apply the same thing specifically with the product. I think it will be easy. But the use case that you mentioned, it's nice to see. For example, and validate this process with the humans. If, for example, if you have ladies on one column and gentlemen on the other column and put the face of the photo of their child in the middle, so to find out, is it really similar, is it working, is it valid or not? Maybe Match.com's next feature.
Yeah, based on the child photo. Yeah. So all of those attempts, they based on the visual element, but it's really interesting to have text as input, and this is the place, I think in 2017, a group of scientists, they tried to create a stack GANs. There is a different architecture, I put some here, you can read about them, but stack GANs, one of the interesting one. And the architecture has 2 layers. On the top, as you can see, we will pass the text, we create an embedding for the text, and we will add some noise, and then creating a rough idea about the shape of the requested. So for example, if you ask about, for example, if the text asks to generate a photo of a bird, so it will generate a rough idea or very, I think, primitive image of a bird. And then in the second phase, we will try to improve the quality and add more informations, backgrounds, or features to that image. So in fact, it has 2 phases, as I mentioned, and it integrates the text or accept text as an input. And this is just some comparison between different models in this area. The input text, the output image, and we can see how from the beginning it was really difficult to understand or to distinguish the object, but they get better and better. I will skip that one.
What was the, there was a term on that called conditioning augmentation.
Augmentation, yeah.
Explain that.
Yeah, so in fact, when we try to change different aspect of the output, we can use the text to and add some conditions to, for example, augmentation. In fact, when you, let's say, for example, in this case, if you want to have extra elements, how we can add that? So this is the place that condition augmentation can play a role and help you to integrate that new features.
Right.
Yeah.
So augmentation as in add something to it, and then conditioning is, what's the conditioning piece?
Exactly. But from the technical, I don't want to dive into the technical, but I'm just trying to be on the surface. But the concept is the same, yeah. In a very simple, I think, example, yeah. So I put some resources, if you like, to really read about them. You can go and check those information. There are some papers, original papers, or sample codes from Google. If you like, you can review them later on. Diffusion model, the next generation of generative AI model that really boosts the whole area, specifically in the audio and the visual element, I think, generation, was diffusion model. The diffusion model based on the reverse diffusion concept. What does mean reverse diffusion? So, in fact, in diffusion model, again, we don't have any label. We have an input. And we try to add noise in different steps. For example, n step. So, in each step, we add some noise until we cannot recognize the original input. And then we push the model to remove the noise from the last one. So this is the denoising process. Why we want to do that?
I don't know. So,
Yeah.
so you effectively say, take this thing, mess it up, and then rebuild it back to how it was.
Exactly.
In order to understand the original.
Exactly. If you remember the autoencoder, we try to give the input, regenerate the same as the output. If we look at the same, I think it's a very similar concept. We want to generate the noise. Why? Because we want to create an algorithm or techniques to create new data from noise, in fact. So the last step will help the model to regenerate the same things by removing the noise. So in fact, we will add noise every time, and this second part, or the denoising process, will be look like that. So we have the noise here, and then we have a trained model. It will try to find the noise from here and remove this noise from the noisy photo.
So that's a mechanism for
Exactly.
self-training, right? Take this perfect, make it messy,
And
and then try and get back to this thing, and then so it'll learn from and can validate itself.
exactly.
It's got the right answers to start with, right?
And we will, for example, if you have an end step during the adding noise, we will try to follow the end step again to remove the noise. And at the end, we will get the same output. So, as I mentioned, it could be applied, the same concept could be applied for the audio. And in each step, when we try to remove the noise, after removing the noise, we need to add a little bit noise again to avoid the problem. And this problem is the average of the whole shapes. So in fact, if we don't add a noise, when we remove subtract the identified noise, the output will be look like that. It tend to generate a shape or an image that is very close to the average of all the images that has been trained on. But every time by adding a sample noise again, we try to push and help it to generate more realistic photo. I'm trying to very simplify the concept. Hopefully I will not destroy the concept, but this is the basic or the very simple, I think, concept behind that. But if you try to look at the architecture, so from the top we will pass the original data, we try to use the encoder and create a latent vector to somehow change the information. Then during the end step we will try to add the noise, making a noise. Then this is the place, I think this is your answer for the last question that you asked. So the conditioning part is coming here. For example, we have a semantic map, or maybe we add some text to change the input or rephrase, for example, entities, or maybe we want to, for example, feed another image to use that image and combine with the current image. So this will be some sort of conditioning that we try to input as an extra, and then we will start the process of denoising, and at the end we need to receive the same output as a input data. I will avoid to dive into the detail, but if you can see, there is a three main component, Q, K, V. I will explain because they are all based on the transformer architecture in the next slides. And DALL-E 2, Leonardo, I think we have Midjourney, lots of those kind of diffusion model who they try to generate visual elements specifically. And I used the diffusion model to generate the Boris Johnson's audio at the beginning. So it was an example of that. Okay, is there any comment, any question? Is it boring? Is it interesting? Is it?
It's really interesting. I'm just like, it's on the edge of what I can conceptually grasp. So I don't want to ask a question without kind of sounding stupid.
No, feel free.
Don't worry, because I can do that for you.
No, as I mentioned, this is a really new concept, and we don't expect to, because they are really complicated if you want to dive into the detail. But this is the basics of the new technologies. And
So these different technologies, the latest being diffusion models and the GANs, are you presenting these as advancements on the kind of previous stage?
Yeah.
So, okay, right.
and the last steps is large language models that we try to touch. Yeah.
Yeah, I'm interested to know actually which models we can use to identify whether it's a generated image.
So to identify the content, generated content. So what kind of model do we can use?
Yeah.
So I remember at the beginning they tried to use a very simple neural network, feed-forward one, just by feeding some samples. Because the distribution, specifically for the text, the distribution of the words in the generated text compared to the text that is written by human is really different. So it's so easy to identify the difference. But with the visual element, again, I think, feed forward still one of the options. But there is more architecture, and specifically combining different solutions together is one of them. Diffusion model, for example, is an option when you want to distinguish between or GAN, as I mentioned, because always we have the discriminator, and if you take just the discriminator, you can use it as a validator for validating the data. For example, is it a synthesized data or is it a real data generated by human?
But in that case, like a particular model is trained on a particular type of data set, and if we want to check for
We don't have
image, basically.
we don't have a general model that can identify. As I mentioned, this is the main problem that scientists couldn't solve before the DeepMind research in the Google. So in fact, we couldn't distinguish different type of, or we hadn't have a model that can identify, for example, image, text, or video altogether. But with the watermarking techniques, now when we generate the data, you can add some extra information which is hidden, is not visible, but is identifiable by the model that can distinguish between them.
I suppose just on related to the diffusion, like that's moving forward. But what's the value there? Is it going to accelerate the training mechanism? Effectively accelerate how quick the model can learn? I mean, that's kind of what I got from it. Is it an enhancement to training?
There is different techniques to enhance the process of the training, specifically with distributed training. So, for example, when you want, I think this is common for all the generative AI model, you cannot train on one system. So you need to have a large data set and then distribute the training on. We have three type of techniques to do that. The first group is distributing data sets on different nodes and the models. So one model will be trained with a part of the data on one, for example, cluster.
Right.
The second part of the model trained using other part of the data on another cluster. So this is the distributed. Or sometimes we will try to distribute the weight of the model on different cluster, but the data set is same. So the model will be trained on the whole data set. We will not cluster or divide the data set for different chunks. And the last one, when you try to train multiple models instead of one model and then get the output as an average of those models.
It's a combination.
Yeah.
Is that a clustering?
It looks like it, clustering them on different places. As I mentioned, there are different techniques, but three main, I think, approach to at the moment for those concepts. Large language model. The last group, we have more, but the last group or concept that we try to cover today, I think I don't need to explain. In fact, those models that they try to generate text, or somehow now we have the multimodal model, who they can understand different modality, text, image, video, or audio together, and we call them LLMs. And they based on the transformer architecture. I will explain what this architecture is, and the basic concept behind this, specifically LLM to generate the textual data is predicting the next word. For example, we have built using deep learning, and the model need to predict the next word in the sentence, or maybe next group of words in the sentence. For example, in this case, it will be technique, then technique will be added to the sentence. Now model need to predict the next word, is it particularly, and again, go on and go on. So we don't need to label anything. We need just to have text, and the model try to predict the next character or word in the prediction. Attention. So transformer architecture is based on a concept which is self-attention. So to understand the transformer, we need to understand the self-attention. Self-attention is the capability of a model to find out the importance part of a sentence, which part is really important, and the relation between those parts. So, fundamental component in the attention mechanism. In fact, in 2000, I think it's earlier, but it's represented by a group of researchers from the Google. They said we need 3 components to find out the important part of the sentence: query, key, and value. Query is look like a questions about one word. For example, if you have, we call them token, in fact, but let's think about words at the moment and simplify. So if you have a multiple word in one sentence, each word can have a query, and this query can help us to find the relation between this word with the other words in the sentence. This is the query. Key. Key, for each word, we can think about some tags. So the key is look like a tags that provide some information about the current word. And then the key with the query will help us to find out the relations between the words in the sentence. And the value is the actual value of that word. So if we try to visualize the attention mechanism is very simple. For example, I like running, very simple sentence. Each word has a query, key, and value. Then we take the query and the key for all the words in the sentence, multiply them together, then we will apply a softmax. I will skip that one. So it's a very simple mathematical equation. Then the result will be multiplied by the value, and at the end what we will receive a group of numbers that shows the relation between the words in that sentence, how they are related, and which one is the most important part in this sentence.
Is this related to the vector?
Exactly.
So we sort of represent in sentence tokens as numbers and weightings and relationships.
Exactly.
In close proximity.
That's true.
And so a calculation can be done on proximity.
Yeah.
So can I just ask, so you have a bunch of words and the identifies which one is the most important. What do you mean by the important? Is it in terms of understanding the meaning?
For this sentence.
For the sentence. And this idea is that if you can do that, does that mean you can essentially scan like a really complicated piece of text and just
So the question is that how self-attention can find out the importance, for example, part of the sentence. And if, for example, the input is a large input or we have lots of text as an input, how it can, for example, understand and find the most important. So to answer your question with the visualization. So in fact, if you can look at that, this is a example. For each word, it tries to find the relation between this word with the other words in the text. So how it tries to calculate that, as I mentioned, for each of those words, we have 3 pieces. And we try to find those pieces at the beginning and run the calculation. In fact, the important piece for example, for each word, when we have, for example, let's say, if you go back to the rabbit, so the rabbit relation with the hot is higher. So the important part for the rabbit is hot. In fact, this is the attention. When we say self-attention, it means this word or this part of the sentence has a correlation or more relation with the other part of the sentence. And this can help to extract the context of the, in fact, text when we try to create the embedding for the text. I don't know, does it make sense or shall I explain more?
I think it makes sense.
I think my understanding is that the context is derived, the importance is derived from the context of the sentence, and that's due to the mathematical relationships between. So you can do a calculation to say that these 3 words cumulatively mean something that's sort of bringing it together, a sort of heaviness or a gravity to that sentence.
Yeah.
Because of the relationship, so that these are related, that seems to be the sentence. Do you go for that sort of sentence?
Yeah. Specifically, I think I will show that one. It will, because you will see how it will work in the next slide. I will try to explain. But when we have a lots of text, so we train the model with large amount, because we say large language models. They see each word compare inside different sentences and the relation of this word compared to the other words in the sentence, and then they try to grab these relations or store the relation between the words compared to the near or the some sort of words near to that one. So in fact, it will help to understand the context based on that. I think in the next slide, I will try to use the Financial Times animations for the generative AI, and it makes more sense to understand what is the meaning of the attention. So now we have the attention, self-attention mechanism. The transformer is an architecture based on the self-attention. I think it will be a little bit complicated, but what we have 3 components in the transformer architecture. The first one is attention mechanism. In fact, it weights the importance part for each word in relation to the other words. So self-attention try to help us to find out the importance or the relation between different words in our process. Then we have the learning connections. We will pass data and the model will see lots of samples of one word, and it try to understand the relation of this word with all the other words and somehow learn when this word should be presented and predict the probability for this word to be the next word in a sentence. And parallel processing for transformer is one of the main advantages when you can process multiple sentences in the same time or multiple paragraphs. and run those processes on different GPUs. The architecture is a little bit complicated, but if you like, I can go dive inside that. We have two-part encoder, decoder. Inside the encoder, again, we try to use the self-attention to generate some sort of, I think, representation of the word. With the decoder, we try to predict the next word, and sometimes predict the mask part of the sentence. And we have a different kind of models. For example, ChatGPT is based only on the decoder. They didn't use any encoder in their architecture. But for example, Google BERT is used, both of them. So they are flexible and you can play around that, and based on the use case, it could be tweaked. So let's show that one, I think. Is there any comment, any thoughts? Otherwise, I think this one clarifies lots of things for us. Yeah.
I was going to ask how you understand the tone. So I understand that, yeah, by predicting the relationship of those words, he knows, can predict the next word and then the next word. But then how does now understand the tone?
The tone or the context, you mean?
I mean, like, if you try to generate a text using maybe like ChatGPT, you could say you want to sound formal.
Oh, yeah.
Or you want to sound informal.
Yeah, so in fact, with those kind of, after the training, the system can distinguish the way that should provide a different tone. So I forgot to repeat the question, sorry, for the online participant. The question is that how the models can understand the tone and how they can generate, for example, formal text compared to the, for example, different kind of text. So in fact, when we try to train with a lot of data, the model can distinguish when you say, for example, this is a formal text, or is it there, for example, a friendly conversation, or so it will, as I mentioned, the context, it will be emphasized for the model, and it can be differentiate between them by itself. And sometimes there is other techniques specifically. For example, if you want to use a model in a specific domain, we will try to fine-tune the model instead of, for example, use a general one. Or maybe you can tweak and use the prompt engineering technique to push the model to provide the desired output. So for example, when you try to send the information in the prompt engineering, we have a different part for each prompt. We have the system part, we have the human part, and the assistant. So it will be repeated, and you have, with those components, you can tweak the behavior of the model. Yeah, so in this case, yeah.
In relation to like the question you asked, like rather than a different tone or maybe in our scenario like different context, is it so like I know a bit of like training the model, so you've got like the embedding database, right? Like on the vector database. Is it essentially like tone context is actually just like another like a database for that, or is it like a subset of a model that trains those tone or context?
No, I will explain the process of the training in the next slide, and you will find out how it will learn to be specific about the, for example, part of the process. But no, in the process we don't have any, for example, they are not going to divide the data set, for example, for different sections. Let's say, for example, we have some part of the data set is just related to, for example, formal conversations. Some part is about, for example, daily conversation. No, we don't have those kind of concepts. And the model try to grasp all those, I think, context by itself.
I think, so the question was, given a different tone or like application to a sentence generation, are there different models that represent those different tones? I think the question was, I think the answer was no. It's the same model that represents but understands the tones. Is that
Exactly.
yeah?
Thank you.
So it knows. So it's more the prompt pushing the model to one area of the sentiment or the tone that's been requested.
That's true.
And is that related to the styles kind of approach for imaging, where it's a differentiation on
The
the
images.
output?
Yeah.
Okay.
Yeah. We have the same concept. So we are just talking about the text, but the same concept is applied in the other modalities. So in this case, they created very nice representation. For example, at the beginning, for training LLM, we have some text data. We need to broke this text to tokens. So this is the first part of the words. We call them token generally. So for example, we go to work by train, and then now if you look at the work, so because we pass lots of data, terabytes of textual data, and the model see works in different contexts. Okay, so based on those contexts, the model try to understand the meaning of this word compared to all other words. And this is the place now the model can see how, for example, a specific word like a work can be related to the others. And then, based on those concepts, we will receive a embedding. So as you can see, based on the work in different contexts, the numbers are different, dynamic, because the context is different. And then finally, we can say and decide this is one representation for work, but just for work without any context. But if the context change, it could be completely different. So, and as you can see, the word with the similar concept, they have a similar embedding or representation. And if you try to plot them on a 2D diagram, in fact, the word with similar meaning, they will sit close to each other because they have a similar meaning. And now, there is an interesting part. So, for example, in this case, I have no interest in politics. No, in this case, for example, we try to explain the self-attention to answer your questions. So, no is the main word, and we try to find the relation between no with the other words. And before the attention, always we try to start from the beginning of the sentence, find the relation, each word with the following text, but with the attention it completely change. The transformer can accept the sentence or a large amount of text and find the relation between those words at a time, and then they can find the meaning. For example, in this case, interest is mean we don't like, but maybe the same word in the different context has a different meaning. For example, the bank's interest rate is rise. Now the interest is referred to the bank interest, not about so the context is different, and because of that, the model understand it is talking about the percentage of the interest. And if you have a sentence look like that, I have no interest in hearing about the rising interest rate of the bank. So we can see the first interest is about it has a meaning, look like a like, but the second one, and the relation, so this is the self-attention. The relation between interest with no in hearing is higher compared to the other words. At the same time, if you go down, the relation or the attention between the interest with the rate and bank and rising is higher. So this is the place that attention mechanism can help us, or can help the model to get the feeling of the oral conversation.
Or it feels like a kind of clustering.
Exactly.
Really. So it's trying to find the most interesting or related set of numbers, which are tokens or words, and pulling those together as the epicenter of that sentence. So it's a kind of working out the cluster itself. So it's underturning.
Exactly. It depends on the words in the sentence and how they are related together. And then based on that, so we have a different group of words, as you mentioned. They can find similar or synonym for the same words. And it can replace the word with something else, or, for example, in this case, the dog chewed the bone because it was hungry. So, in this case, it referred to the dog. Is it true? Yeah. Because it is referred to the dog. Dog was hungry. But if we change that one to delicious, because it was delicious, now it referred to the bone, not the dog. So this is an important concept that large language model can distinguish all of those from each other, because it's so lots of text during the training.
And it's the subtleties that are worked out through the calculations. That's just a close through the calculation, and presumably then the tone, you could replace things like I'm not interested to I'm less interested, and because it's related.
That's true. Yeah. And so now it can go forward and predict the next word based on the understanding and extract important information, for example, about each in a long context, so it can extract the important information for us and help us to understand the context better. So again, those some sort of basic, but one of the other concepts I will mention that one, and we will try to wrap up the session, is about the predicting. Sometimes we try to just predict one word, but it not make sense, and it's better to maybe predict a group of words or phrases. So we have some techniques, in fact, that can help us to predict a group of words to complete one sentence, such as a beam search, for example, which is one of the techniques, but we have other kind of techniques, and it can improve the quality of the predicted or generated text. Yeah, so I think you can go through these nice article from Times, and it's really interesting specifically to understand what is going on under the hood for the large language model. Back to I think I have just one other slide, and it is about the training process. So in fact, when you want to train a large language model, I picked a Llama 2 from Meta. So they almost gather around 10 terabytes of text from the internet. Then they use around 6,000 GPU for 12 days to train the model, and the cost was around $2 million. So in fact, at the end of the training, they created a model. The size of the model was around, Llama 2 70 billion parameter version is around 140 gigabytes. So this is just numbers, the weight of the a model, and you can write a code, I think around 500 lines of code to use this model and put this model into production and push the model to predict and generate text for you. But what is the process of the training? There's a 3 main steps for large language model training process. The first step is creating a base model. So you have for example, they gather all those information, the text, they feed the text to the model, they train the text based on 10 terabyte text, and they didn't do anything. They just tried to push the model to understand the concept and predict the next word. Then the second step is fine-tuning. For fine-tuning, because the information, you cannot validate all the text inside these 10 terabytes. So they ask a group of expert people to create a conversation, look like that. So there is as I mentioned, a prompt engineering technique. So they said, let's write some questions and provide answer for those questions and feed those samples as a training data for the process. I think for Llama 2 they used 100,000 samples for fine-tuning the model. And finally, reinforcement learning from human feedback. So then when the model fine-tuned, a group of other people try to use the model and get feedback to the model to fix and improve the quality of the output.